morning, friends. My name is Rituraj, and today we are going to continue our series of chapter DC circuits. And today I am going to start a new topic, that is nodal analysis. So, in previous lecture we had discussed mesh analysis. Now we will discuss nodal analysis. The output will remain same, but our method to solve the question is different. Okay, so I will just write here. Okay, so just like previous lecture, I will first write all the theory part. You also note it down. First point, this method is based on Kirchhoff's current law, that is KCL. So now once again discuss Kirchhoff's current law. So Kirchhoff's current law states that the algebraic sum of the currents flowing in a node or coming out from the node is 0. So moving on for the second point. Second point states that first node voltage is determined and then current is determined. So I will just frame it within good sentence. So in this method, first node voltage is determined and then current is determined. Okay, so talking on the third point. So why this method is better than mesh analysis? So as we had discussed in mesh analysis, that in mesh analysis the number of unknown currents is equal to the number of mesh. So if I consider there are 4 mesh in a circuit, then there will be 4 unknown currents which are impossible, which are not impossible, which is difficult to calculate by a scientific calculator. So in such sums, use this nodal analysis. Okay, I will just frame it in sentence. This method is useful where there are more number of mesh. Coming to the fourth point, this method requires less number of equations. Okay, so you all first note this down, because these are the questions which come directly in theory questions, such as I will say write a short note on nodal analysis. So you must write these 4 points and support it with example. So please note down. Okay, so now moving on for question. So this is our first question, and this is our circuit diagram. it is containing 3 mesh. So if we decide to solve it with mesh analysis, then we will have 3 unknown currents equation, and we need to solve 3 equations, and it will be quite tedious to write those equations. So now our question is to find current through 5 ohm. So this is my 5 ohm. So in this question there are 2 nodes. This is my node A and this is my node B. Okay, so now we need to apply KCL law. First we need to consider some branch currents. So I will say here is I1, this is my going to be I2, this is my I3. Now I2 is flowing through this branch, so here also it will be I2 only with the same direction. This is my I4 and this is my I5. Okay, so once again our question is to find current through 5 ohm resistance, which is here. So indirectly we want to find I4, which is flowing through 5 ohm resistance. Okay, now let's apply our KCL law at node A. I will write it here, hope it is visible. So I will write here KCL at node A. Okay, so KCL I1 is equals to I2 plus I3. So we had discussed this in our first lecture. Okay, so now I will just write this equation. So you all might be aware with the concept of voltage drop across a resistance. So by Ohm's law we know that current is voltage drop upon resistance. So for resistance 1 ohm, what is the voltage drop? It is 20 minus VA. Okay, this is VA volts. Okay, so voltage drop across I1 is 20 minus VA whole divided by 1 ohm is equals to, now I2 is flowing through a resistance having value of 10 ohm. So now voltage drop across 10 ohm will be VB VA minus VB. So while writing any voltage drop, we need to consider first initial voltage minus final point voltage. Okay, upon 10 plus I3. This is my I3. It has VA as its initial point voltage and 0. Let us consider this to be ground. Both these nodes are ground. So it will be 20 upon 2. So on solving this equation, I will just solve it and write the final equation as our equation number 1. Okay, so there was a small mistake. I had wrote 20 here. It is VA. I just by mistakenly wrote, and this is our final equation as equation number 1. So now let's apply KCL at node B. So how many currents are there at node B? I2, I4 and I5, where I2 is coming towards the node and I4 and I5 are going out of the node. So by KCL, my equation will be I2 is equal to I4 plus I5. Okay, so now I2 will be VA minus VB whole divided by 10 is equal to I4 will be, again this is at 0 potential, so my I4 equation will be VB upon 5 plus, now I5 has an interesting equation. It will have VB as its initial point and its final point will be first here, and it is 15 volts, but as it is on the other side of the resistor, though it has a plus sign, we will consider it as minus sign. VB minus 15 whole divided by 2. Okay, so this is a correct equation, and I will just simplify this and write. Okay, so guys, after simplifying this equation, we get this as our equation number 2. Now we will just solve both equations with the help of our scientific calculator. Okay, so I am also calculating it side by side. So 22 minus 2, 200. Next is 1 minus 8 minus 75. Okay, so on solving, my VA value is 10.05 volts and my VB value is 10.63. So now we have got VA and as well as VB. Now what's our question? So question is to find current through 5 ohm resistance. So we need to find I4 for that. So now I will write here I4 is equal to voltage drop across I4 is VB upon 5. Correct? So on calculating, 10.63 divided by 5, 5 2s are 10, 5 1s are 5, 5 2s are 10, and 5 6s are 30. So answer turns out to be 2.126 ohm. Sorry, it's amperes. And now writing the final answer. This is very important. I5, which is equal to I4, which is equal to 2.126 ampere flowing in downward direction. Mentioning this direction is very important in university exams. So you can cross check the answer by solving the same sum with the mesh analysis method which we had discussed in previous lecture. Now let's move on for the next question. You please note this down. So friends, this is our new question. It is more amazing question, and our final question is to calculate current through 10 ohm resistance. Is how much? Okay, I just forgot to complete the question, but this is an amazing question because in this you will see a current source as well as voltage source in this question. So here we are having 1, 2 and 3 nodes. So let's flow the current in this circuit. So this is my I1, this is my I2, this is my I3. So as we all know KCL law, so I2 is flowing in this branch and 2 amps is coming out from that node. So current through this remaining branch, I will call it as I2 minus 2. Okay, this is a point to be noted. It is I2 minus 2, and through this branch I will talk current to be I4 and this be I5. Okay, so now let me check. Okay, I will just make a small change. Let's name this as I5 and this is I4. Okay, so now let's continue the question. So I will write here apply KCL at node A. This is my node A, this is my node B, and this is my node C. Okay, so I will just now go fast. I1 is equal to I2 plus I3. Next, let's write the voltage drop also. 10 minus V1 upon 100, which is equals to I2 Now here in this branch seems to be no resistance, so we will keep it as I2 only, and we will write here plus I3, which is V1 minus 0 upon 20. So this seems to be quite ambiguous term, that is I2. So let's keep this equation as this only and move forward. We can substitute this I2 value from other equation. Okay, so apply KCL at node B. So this is my node B. So again I will write I2 is equals to 2 plus I2 minus 2. Okay, so again I will write I2 is equal to 2 plus V2 minus V3 whole divided by 20 ohm. So we will substitute this I2 value in this equation, and on substituting these values we get our final equation as minus 6 times V1 minus 5 times V2 plus 5 times V3 is equal to 190. I had already solved this, so I am having direct equation, but I will request you all to substitute this in this equation and solve it. Okay, so I will name this as our equation number 1. Okay friends, so moving forward, let us focus on node C. Okay, so I2 minus 2 is equal to I4 plus I5, correct? Yes, correct. So I2 minus, this is having voltage drop of about V2 minus V3 upon 20, which is equal to I4, which is having voltage drop of about V3 upon 20 plus I5, which is having voltage drop of about V3 minus 100 upon 10. On solving this equation, I will just write our final equation from this. So we get our final equation as 2 times V2 minus 5 times V3 equals minus 100. So I will just name this as our equation number 2. So friends, a point to be noted that here at node A we are having voltage as V1, but as we know that this wire is having an equipotential surface, so V1 has an is equal to V2 if we can join also these two nodes, because there is no resistance present in between. So I will write here V1 is equal to V2 and write a reason here as equipotential surface. Okay, so this equation again gets reconverted. V1 is equal to V2, so we will also consider two equations in V2 and V3. So on solving we will get minus 11 times V2 plus 5 times V3 is equal to 190. Okay, so I will name this as equation number 3. So on solving 2 and 3 we get V2 value as V2 value is minus 10 volts and V3 value is 16 volts. Sorry. Yes. So now what does this minus 10 volt sign indicates? So we have considered this is V2, so we have considered the current to be flowing like this, but current is not flowing like this, current is flowing in this direction, so it is denoting our minus sign. So moving on for the question, we need to calculate current through 10 ohm resistor, which is I5. So now I5 is equal to V3 minus 100 upon 10. It is 16 minus 100 upon 10. I will just calculate it on a calci. So it turns out to be minus 8.4. Now why this minus sign? So this denotes that my current is not flowing in this direction, it is flowing upwards. Okay. So I will write here the final answer, which is more important. So I through 10 ohm is equal to I5, which is equal to 8.4 amp flowing upwards. This is my final answer of this question, where writing this is very important. Okay, so you can note down the question. Now I will give you one more question as your homework, and I will also mention its answer also, but the process is yours. You can also solve this question with mesh analysis, but you will get 4 unknown equations, or you can also use a source transformation and convert it into a question having 3 mesh with 3 unknown currents, and you can simply solve it in that ways also. So please note this down. Okay, so this is your homework question. Okay, this is a simple circuit in which here you need to use some of your brain, and the question is to find V1 and V2, and I have mentioned the answers for V1 and V2 here, so you may solve it. And you can also solve this question with mesh method also, because 1, 2 and 3, there are 3 mesh and 3 unknown currents, so it can be easily solved. You can solve it if you want.